So today's session is all about Open RAN radio site selection and installation. And our today's focus is will delve into one of the most critical steps in deploying an Open RAN. So choosing the right location for the radio components and correctly installing them. So site selection involves determining the optimal places for radio nodes to provide the required coverage and capacity while minimizing costs and avoiding interference. Our speaker for today has 15 years of more than 15 years of experience in telecom industry, and he has become a specialist in traditional and O-RAN networks on NR or 5G, LTE, UMTS, and GSM. His expertise in pre-sales, training delivery, parameter optimization, and network planning of radio network access or RAN. Currently, he's working with Rakuten Symphony as a pre-sales, and he also earned a Bachelor of Science in Technology and degree from RGPV University in Bhopal, MP, India. During their free time, so he also enjoy indulging in hobbies like bike riding or trekking and camping. So exploring new places is their passion. Okay, ladies and gentlemen, let's welcome and let's give a virtual warm of applause to Abhishek Dubey.
So this is the agenda for today's session. Obviously, we'll start with a little bit introduction with the introduction of Rakuten Symphony and Rakuten as a whole, and then we start the fundamentals of candidate selection and site installation procedures. We will learn why candidate selection around the nominal while you're planning a network for the operator is very important. So here we are going to talk on O-RAN perspective. So I will also explain what is the difference between O-RAN radio planning and overall planning and the traditional RAN overall planning. A radio site, there would not be much difference, but in overall planning, which comprises our E node B, there is a significant difference that we are going to see through architecture, and we will understand how it is important that the site selection in the target area is and then what the points main points you need to consider while you are working as a planner for a client or for a customer. As well as we will also discuss the site installation, because the first step is a site survey and candidate selection. Once you selected the right site on the basis on the nominal priority, the second step is site installation. All right, so you are going to install the site with all the equipments. So we'll also understand, and I will explain that what is the difference between the traditional and the O-RAN, because in traditional, what equipment you need to send to the site for the installation and what equipment you are going to send for the installation on the site in the O-RAN. So there is a difference between both. We are going to see that, and after that we will see in detail what is the candidate selection process in the O-RAN deployment and what is the site installation in the O-RAN deployment. So this is the agenda for today, and welcome everyone. Let's start. So this is about the Rakuten. Rakuten is so we have a Rakuten group as umbrella, and within Rakuten we have many companies. It's around 20 plus or 30 plus. I don't remember the exact number, but it's many companies, and one of them is Rakuten Symphony and Rakuten Mobile. So Rakuten Mobile is the operator for Tokyo for Japan. for Japan, and Rakuten Symphony is a global OEM who is contributing in O-RAN deployment. So we have presence in different countries, as you can see in the screen. We have presence in Japan, in Southeast Asia, in India, in Middle East, in Germany, UK, and in Americas. So we have 1,500 plus R&D engineers who are working for the feature development and O-RAN development. And also we have engagement with the telcos and the government as well as enterprise for telco grade network deployment and for private network deployment. A little bit about the Symphony, because I am from Rakuten Symphony. So we are providing digital platform for the businesses. We are defined by the software because our approach is a software centric. The reason is Open RAN is all about decoupling hardware from the software. Okay, so if you consider the traditional RAN, there is a hardware for each applications. Okay, but here we have a hardware. That hardware could be from any manufacturer. The condition is that should be a GPP quad-space hardware, and on any hardware that is with that specification, we can host our workloads, and that workloads is any telecom workloads. So we don't require a separate hardware for separate applications. Okay, so this is our approach, and also we are focused on the creating business values. We are open, transparent, and secure. Our mission is to improve customer experience that should be affordable, exceptional communication services for them, and enabled by the next generation technologies. And also we are solving telco challenges, whether it's a cost pressure reduction, because our deployment is reducing capex by around 30% and opex around 40% for the telcos. Because we are reducing the cost pressure on the telcos. Also, we are introducing new source of revenue through the innovation, and there is zero security concern, and so there is no talk on the security with the O-RAN. There is a many rumors in the industry that O-RAN is not secure, but there is nothing. The squad introduced one later on the security. You guys can read that newsletter, that there is no security concern with the O-RAN. So what we are going to see today, or if you remember in the previous session, I explained you the design and planning of our O-RAN deployment. So these are the ecosystem from the Rakuten Symphony what we are supporting for deployment of our Open RAN. And why it is necessary to show here, because the tools which we are going to use in the planning, designing, and the candidate selection or on the survey, that is part of Symbiote platform. Okay, so this is the cloud which we are offering for the customers, and this is the network. So that could be a 4G network, 5G. For if you talk about the planning, or these are symbol for like the site manager, inventory manager. These are some other tools in our portfolio which is going to help in site deployment. So that is what we are saying. That is what our approach is, to minimize the go to market time for the site, so that the minimal time it take, and all should be automated. That is how we can minimize the time for the deployment. So one platform and each and everything, whether you start from civil work, nominal planning, or when you plan the nominal, then there should be a warehouse management. You will send the equipment to the site, so that transport handling and everything Also, when equipment is there, you need to install. So that tracking of installation and which material you have installed on the site. So each and everything tracking, and everything is automated here through the SimWorld. So this is what we are doing, and that is how we are reducing the cost and also reducing the time for operators. And that all is recognized by the different organization that you can see here. All right, so let's just start with the fundamentals of candidate selection and site installation. So first part is why is this site selection in appropriate location is important. So that is what we are going to see. So first thing is this is first and most important transition from planning to deployment. We have to ensure that we are choosing the base site, and the site should be in the strategic location that ensure properly functioning network and effectiveness of the end user. Right. So all the process, whether it's a construction process or building the cell tower or a big tower, a small tower, that all is required there. And also the why it is important cell site selection, because through best cell site selection you are going to ensure that whatever coverage or capacity requirement asked by the operator or asked by the client is going to fulfill. Otherwise, if let's say if there is a location, there is a small location where customer ask you to plan a site. So you started planning a site in that location, but obviously you have to define multiple nominals, right? You have to define the priorities P1, P2, P3, right? Priorities. But if you're not get the P1, then you have to select the other priority P2 or P3. So you have to ensure that through that deferred nominal selection or deferred site selection, you are meeting with the coverage and capacity requirement. So that you need to ensure. And if you remember, I was telling you in the introduction that there is a minimal footprint we are going to install on the site. So this is the Rakuten ORAN site deployment, which we have deployed in Rakuten Mobile. And the footprint, if you are already working the traditional RAN, if you can compare easily, that footprint what we have installed on the site is very minimal, right? So this is the antenna, all right, installed on the pole, right? So antenna is same what what you have installed in the traditional, and our antennas are integrated with the RU or ORU. So you cannot see separate ORU on the cell tower. So only 3 antennas. Obviously, you require the power to run the active modules, and there is a rectifier in the battery. If it is available, you can install DU on the site. Otherwise, DU you are going to install in the data center. It could be a edge data center. As I explained in the previous session, it could be city pops or district pops or RDC, regional data center, or CDC. So depend on the latency calculation uh, that is required to calculate the location of this DU or the CU, and based on that you can decide whether you are going to put the DU on the site or on the data center. So let's say if DU is on the site, that is what footprint you are going to have in the site. It's very clean, very minimal. All right, I will also tell you in the next slide, in the coming slide, that what footprint you are going to see or you're going to have for traditional versus ORAN. So let's little bit discuss the installation process. I believe most of you are already aware about these processes because you might be already working with some operators, some telecom companies. So, so first of all, it is important to go for the nominal plan and the site survey. right? As as I told you, nominal plan. While you're planning a site, the first step is to plan nominal and survey the location and some other possible candidate in 50 meters. Okay, so if you plan one site here, let's say if this is the location and you plan one site here, and that should be your P1. But let's say this P1 is not possible. So what you need to do, you need to circle one area and find out the possible location nearby this P1. So maybe you can find one more place where you can make the agreement for the site. So you can go for this. You can survey the P2 option, priority 2 option. Let's say if there is another option which you can named it as P3. So these sites also need to be surveyed, and there is a detailed explanation on the survey of how this can be performed. So you have to survey everything, like whether the infrastructure is appropriate to install the tower or not, the power requirement, where you will receive or you will get the required AC connection from that in that place. If it is on the building, on top of building, then from that premises or not. Civil infrastructure, obviously you need to focus, you need to observe and survey that, and then you will survey the entire location. Okay, the 360-degree of location, and there should be a plan while planning the nominal, that what is going to be orientation of your site. So you will see your focus will be the main orientation is clear or not. There should not be any obstruction in form of building or any other cell site, tower, or any other things. There should not be any kind of obstruction on your main orientation or in main lobe of direction. And also your clutter should be clear on a certain extent. Okay, then all the site need to be follow the same procedure, and then you will survey. Then you submit this survey report to your engineer or whoever is managing this. Maybe it could be a planner or a survey supervisor. And once it finalized that which site is going to be a final, because let's say if P1 is not possible, the priority was this, but if it is not possible, we cannot get the agreement on the P1, then let's say if we finalize the P2 based on the clutter, seeing the picture of clutter and the requirement of civil and power, then and also the transport. If its P2 is clear, then you will start the installation activity, sending the equipment on the site, and installation of your all the equipments. It could be antenna, cable, power systems, right? Everything. So first you will install the foundation. It includes the civil infrastructure and the power, and then subsequently you will install the poles, and then antenna and the cables, and the DU or RU, whatever is required on the site. So this is the wholesale activity what you are going to do in the installation for a site. So as I told you, there is a certain or a degree of change in the equipment with what you are going to send on the site for ORAN versus traditional RAN. Okay, so this is what you are going to send on the site for the traditional site deployment. So there is a BBU, a bigger site which you are going to send. Maybe it could be a 19-inch rack where you're going to install the BBU. Apart from that, you are going to send the RRUs on the site, the power rectifier, battery rectifiers, the cabinet, obviously, all the jumper cables, antennas, so that all is there. But if you compare the ORAN part, it is simplified. Only the okay. So only this part, and in the civil part, you are going to install the power distribution unit and the battery and the rectifier. Okay, so these are part of civil, and this is part of your telecom installation. So very minimal footprint you are going to send, and this is going to speed up your installation or deployment of your sites. Right. So faster deployment and innovative automated operation you are going to see with the ORAN site deployment. Now, if you compare with the architecture wise, so this is not all about like I explain you what things you are going to send on the site. But if you compare, so for ORAN, the eNode B, or you can say the 4G site or LT site or 5G site is this. But for 5G, this is not the complete site. Okay, this is a part of site. So to explain what is a complete site, 4G site or 5G site, this architecture you need to understand. Okay, if you're new in this session, if you've not attended the previous planning and design session, then this could be a new for you. So these are traditional site, everything is on site, whether it's a 4G or 5G. Okay, for 5G, some operators are using distributed architecture. For them, it's not applied, but if that operator is still on the BBU concept, baseband unit concept, then this is the architecture they are following for 4G and 5G deployment, and this is ORAN deployment. So this part will be on the site, and this part will not be on the site, it will be in the data center. Okay, that could be a edge data center, regional data center, and centralized data center. So we have divided like the DUs you are going to deploy on the edge data center. Okay, so this is just some names which we have categorized based on the limit of those data centers. So obviously by the distance to the site, you can understand these data center will handle limited number of sites because some limitation with the front haul and the bandwidth and the latency, and other data center who don't require to install the real-time equipment that can install far away from site due to the relaxed latency on the mid-haul and the mid-haul interface and the backhaul interface. So for example, that could be a regional data center and centralized data center. So we are installing here CUs. Okay, both of them, CUCP control plane and CUP user plane, and these are the core workloads. It could be a UPA for EPC, right? And also in the CDC we are installing the IMS which you require for the VoIP call, VoLTE call, the BSS for your pricing and all. For commercial, the AMF is there, and the UDX is there, and RC is there. So this is just example. It can be in the regional data center, or some of them can be in the centralized data center, because in some of the deployment, operator ask you to don't deploy at the regional data center. They will say that, hey, just go with the edge data center or far edge data center and the centralized data center. They don't want to deploy the edge data center. So there is no change or anything with our performance. The performance is not going to be affected if you are going to do so. Okay, this is just a choice of client or customer if they want to go with this option, if they want, or if they want to go with the some of them data centers. Okay, so accordingly we will design the network and plan the network. So this is the architecture we are following the ORAN. Okay, and if you talk about what is the LT eNode B, or 5G Z-Node B in the O-RAN? So let me change the color and tell you. So this RU, DU, and the CU. This 3 is making one E-Node B or one Z-Node B. So this is the difference between our traditional and O-RAN. Okay, I hope you get it. Let's understand the site selection in detail for the O-RAN deployment. Guys, first, as I told you, you have to start with the nominal planning. Okay, so you are working for a customer. First, you have to find a suitable candidate through the nominal planning. So this is the process you are going to follow generally. So there would be RF equipment that you required for the nominal planning. You have to get this input from the customer that what antenna, what could be the gain of antenna, or what could be the configuration of antenna you are going to use. And the next thing is you have to get the frequency and the band and the bandwidth details from the customer. You are going to use the clutter map so that you can see the complete geographical areas. You are going to use the customer data and the services in the prediction that what voice or data traffic model they are going to choose. Okay, this is required because maybe one customer is preferring to have more dominant in the voice traffic rather than the data traffic. So accordingly, you have to see the traffic modeling. Some of them, because nowadays most of the telecom operators is having more dominant towards the data traffic. So if the traffic model is more dominant to the data, accordingly you have to plan the site, because that is going to affect your nominal plan and the sites, then the position of the nominal sites, and also obviously the number of sites, right? The next data is very important, is propagation model. Okay, so if you're part of the previous session, I explained you there are multiple propagation model which you need to follow. There could be Ikegami. So there could be empirical model where you have the Ikegami. There could be a semi-empirical, or the another one is the detailed one, which we need to direction or directive. I forgot the name. So that is a detailed one, which you need to follow. So if you are going with the Ikegami, the empirical model, there could be a certain feedback lacking, and you need to perform again. This you need to fine tune your plan again and again. But if it is semi-empirical and the last one, which is feedback based, then the model could be more efficient and more scalable. Okay, so that you need to consider the slope in the propagation model, and also the physical parameter of the site. Physical parameter include the height of antenna. Okay, and height of antenna, what is the orientation, what is the tilt. So tilt could be two types: mechanical tilt and electrical tilt. So that all information is you are going to feed in the propagation data. And the last but not the least is link budget. I already explained you. This is the this you can I mean link budget, which is also called that you can link budget you can calculate from the MAPL, maximum allowed path loss. And this maximum allowed path loss is a difference between your total transmit minus what you have received. So in other language, it's called EIRP, effective isotropic radiated power, minus IPR. So difference of this is your MAPL, and through MAPL you can calculate the link budget. Okay, and based on the link budget and all the parameter, you will feed all this detail in the planning tool. Okay, that could be Atoll or any other tool, whichever you're following. It could be Randium, Atoll, or any other, and that all data you put in the tool, and finally you are going to get a prediction plot in the coverage and capacity that you are going to analyze, configuration parameter you are going to analyze, and the nominal plan you are going to see, and this you're going to verify through the site survey. Okay, and if so here you are going to decide the P1 and P2 for the nominal. Okay, P1, P2, P3 for the nominal. As I explained you, in one location, in one target location, there could be a nominal, but around the nominal, you have to also give the option in terms of P2 and P3. So through this procedure, you are going to get these options, and through site survey, you are going to survey all the options and going to made a report based on the clutter photo, the civil infrastructure, the power requirement and all. And if there is any change in the plan, then you are going to input those plan again in the analysis, and again we are going to make the plan prediction plot. So prediction plot actually that gives you that what coverage from the tool, what coverage you can get in that target area. So I will show you in the coming slide how the prediction can be plotted and how you can see the coverage of that target area. And you need to ensure that there should not be any coverage gap if the nominal has changed. Okay, in case you're not getting the P1, the option you agreed on the P2 or P3, then the coverage should not be I mean there should not be any coverage gap. So that you have to ensure through the design verification. So again and again you're going to get plot the this coverage through the tool, and you're going to analyze that there should not be any gap in the coverage as well as in the capacity. So this is the nominal radio planning to find the suitable candidate, guys. The next part is how you are going to find a suitable candidate. Let's understand through one example. So as I told you, always prioritize the nominal candidate, and every deployment is unique. Site selections must coincide with the objective of your project. There should be a target area. Okay, so let's say the target area is a stadium. You are going to plan a site to cover this stadium. Okay, so let's say and let's assume it's not a small cell site. I just try to give you a platform to understand how you are going to plan your site in normal clutter. Okay, so let's take example. You are planning for a macro site, but the target area is a stadium. So planner give you the option that this should be a P1. I mean, if you install the site at this location, you are going to cover this whole stadium with their coverage perspective, and as well as in the coverage capacity perspective. The capacity requirement can be fulfilled as well as coverage requirement. But you're not going to get, or maybe if you get this P1, it's well and good. But if it is not, then you are also going to check the possible options where you can install the site. That is what is the main aim of candidate selection. You are going to survey the possible candidate nearby the location. Okay, so for example, if you receive this as a final, okay, where you can install the site and it is fulfilling your civil criteria as well as or criteria, then again you are going to give this feedback, design feedback to your planner here, and there your planner is again going to feed this data to the tool, and then they are going to get a plot, and then they will decide that whether this location serve their purpose to cover this whole area with the good coverage without any coverage gap, and their objective to get the capacity in that location can be fulfilled or not. Okay, so that you need to ensure, and the planner, as a planner, you need to ensure that whichever candidate you are going to final, that should serve your purpose. Okay, that you need to generate the plot again and again and verify that. So why I'm saying again and again that plot, because that plot is proof of your model, and that plot you need to show to the customer to convince them that the nominal has changed from P1 to P2, and this is the coverage plot and the capacity plot that you are going to show the customer, and you are going to agree them that this could be your final site. So hope this is clear to everyone, and you are getting a little bit that what steps that need to be followed in the candidate selection. Okay. The next thing is if there is a target area, let's assume this is a clutter you are going to plan. Okay. Obviously, you can see by seeing this clutter, you can understand this should be a dense clutter urban or dense urban clutter. So let's say if this is the location, maybe you are working for the brownfield operator. So you have already sites to these locations. You have the sites to these locations. It's already up and running. This is the area where you required a coverage. I mean, there could be a complaint of coverage that the customer is not getting proper coverage, maybe inside or outside the area. So now you have to plan one site here. Okay, so let's say this is your target area to cover. So what you are going to do first, you are going to assume based on the nominal plan procedure that what could be the physical parameter of the site, and going to plot one nominal, and also around the nominal some other P1 P2 options. So let's say if this is the plot you have finally figure out, maybe if this location required multiple sites, maybe one site cannot fulfill all the areas, so you can plan 2 or 3 or 4 cell sites. So if this is the plot coverage plot you are getting, and obviously there will be legend, and legend is saying that the blue the yellow part is good coverage. So almost all areas you are going to cover with this sites. But let's say if the requirement is to plan 2 sites in the area. Okay, if let's say the coverage you are going to plan for this area only. So if the requirement is to plan only 2 sites, not the 4 or 5 sites. So how you are going to plan your P1 and P2? That is what we are going to see for this dense urban clutter. So let's say this is the sites for P1 and P2, but finally, which site you are going to select? This one, because you think that this site can cover most of the areas, or if you include this site as well, it can cover complete area, which is your target area. So this is the just example to show that how you think while you planning area for coverage perspective or capacity perspective. Okay. All right, so let's go to the next part and summarize what is the process in the candidate selection. So for any kind of planning, whether it's a greenfield planning or brownfield planning approach, first you have to start with the model tuning, plotting, the coverage plotting, and nominal finding. And also you are going to find the candidate 50 meters for the possible priorities P1, P2, or P3. All right. The next is coverage gap must be considered if nominal differ. Okay. There should not be any coverage gap or any dense urban or suburban or rural that you are going to consider, because the plan always the planning is based on the clutter type. Okay, so clutter type is must to consider. The next one is a prediction must be done to check coverage gap again and again, because there will be always a verification round after the survey. So you have to get the prediction plot for the coverage again and again. And then the next one is a 4G and 5G site plan might be differ due to the frequencies which you are going to use for the 4G deployment and the 5G deployment. So might be in a certain area you require only 2 or 3 sites based on the coverage plot for the 4G, but in the same area you might require 6 to 7 sites for the 5G. That is due to the higher frequency and the losses due to the frequency, right? So for 4G site there could be a less number, but 5G you might require some more sites than the 5G. So that 5G sites maybe you can take a approach to install those 5G sites on street or any small poles on any government pole or electric pole or anywhere that you can consider, if you don't want to invest more on those 5G sites on the civil part. Okay, so that you can always consider. And although always forecasted traffic is important to predict the future traffic. Okay, so you have to plan that what could be your potential traffic in that area in next 5 years or next 4 years, and based on that you will consider your you will tune your parameter and you will consider the prediction plot. Okay, once everything is final, you have to go with the GSR to the final candidate selection. So this is a process called GSR to select the final candidate. And once you select the final candidate, the next one is TSR, where you are going to implement the physical parameter for the site. Okay, so in TSR you are finalizing the physical parameter, and the next step is to implement those physical parameters on site once it is TI ready. TI means it's installation ready, and now you can configure your all the radio parameters on the sites, and site is installation ready. Now it can be on air. So this is the approach you are going to follow generally. The next one is site installation and ORN deployment. Okay, let's understand. I hope most of you already aware about the installation process. This is just a recap. Who is already working in the ORAN part, but the people who are new to the ORAN deployment or working in the traditional RAN or new to the telecom, that will be suitable for you, because I'm going to moreover cover the ORAN perspective for the deployment or installation of the site. Okay, so not on the site installation means on the tower. I'm also going to cover for a complete eNode B or gNode B deployment what other things in ORAN you have to consider, because it's not a traditional RAN where everything you are going to deploy in the site. Okay, there could be multiple things that is not going to deploy on the site, because we are going to have a lower footprint on site. So that is what is very important to see in this site installation. Else everything is same what you are already doing for traditional networks site deployment. Okay, let's get started. Okay, I hope my pace is not too fast. I'm going very slow, and you guys can understand me very effectively. Okay, please give thumbs up if my pace is okay for you and you able to understand what I'm speaking here. Great guys, thank you. Okay, so let's get started with summary of main installation product for the site, and I'm also going to tell you something about the Rakuten deployment, which we already did in full phase. We have covered 96% of areas of Japan through Rakuten Mobile. So the main component, if you consider for the installation, is again the DU and the CU and the RU. Okay, for us it all are the virtualized and centralized. The site and civil access is important to install your antennas and DU and RU on the site. It's very much important, and also the antennas. So this is the categories or main product which you are going to install on the site. But for Rakuten deployment, there is something else, and that main key factor is that we deliver 40% reduction in capex compared to the traditional deployment model. Okay, the same equipment which you are deploying in for the traditional, or which you are installing for the traditional, but with the ORAN or especially with the Rakuten, we are getting in the antenna RU 70% saving. Okay, the reason is we are using cheaper hardware. The antennas are integrated with the radio unit. Okay, so it's very cheaper. So there is 70% reduction in saving in the capex. The site access in civil, there is 20% reduction because saving on cell site due to the smaller hardware footprint and additional costs for the edge site. So lower footprint in the site give you the 70% reduction in the saving, because the rental will be less because the load on the site is less, right? So your rental will be less. There will be 70% reduction, and also the equipment which you are going to install on site is less. The next part is DU and CU. In traditional, you can call it as BBU, baseband unit. Here we call it as distributed unit and centralized unit. All are virtualized. It's 25% reduction. Why? Because of virtualization. Okay. Why? What is the main advantage if I'm saying here virtualization and centralization? What could be the main advantage for this saving? So that could be if I'll show you again this picture, this site again, yeah. If you consider this site, so please remember this image while I was speaking on that side, that slide, and also this picture. So this is your traditional RAN where everything you are going to deploy it on site, and this is the ORAN side. So what is the virtualization here? For traditional, there is no virtualization because the baseband unit which you have installed on the site cannot be used on another site. Let's say if this is on site location A and there is site location B, you cannot use the resources whatever is left out here to the site B location. Correct. Because there is a limitation on the front haul which you are going to use here. But for us, you can because this is the front haul, and you can pull out multiple sites. And our CUCP is a regional data center. Regional data center means in maybe in 50 to 100 kilometer area, you can have one regional data centers. So you can consider multiple sites you can connect with one CU server. Okay, here one server unit, one site, but in ORAN and split architecture, one server with the multiple sites. So this is due to the virtualization. So whatever is resources, okay, resources means, let's say if you have 32 resource in one single socket server, this resources is counted in terms of P-core. So let's consider if you are having this 32 P-cores resources in one server, and same condition with the here with traditional, if you're having 32 P-cores in this site, so if this site is using only 20 P-cores out of 32, okay, can you use a rest of 12 P-cores for other sites? No, you cannot use in the traditional site, but here you can use the rest 12 P-cores for other site deployment. So this is the advantage of virtualization. Okay, and also our the CPUs or our resources are more optimized. So if traditional required 20 P-cores to run that configuration, we required even less than that. Okay, I'm talking on the high level. That could be maybe if they require 20, we might require 50. Okay, in the same kind of configuration to serve that purpose. So our resources are more optimized and it is centralized. So this is the things I wanted to show you from this slide, guys. So that is why we are getting this 25%. The next one is a cost-effective platform. Why? Because if you talk about the typical operators, they might require to deploy 40,000 sites base station. Sorry, they might require 10,000 of field engineers. They will be using for different work, for site installation, to managing those sites, to integrate those site, everything, the site survey, the RF drive test, all other things. But for us, and we have already verified that with 40K base station deployment in the Rakuten Mobile, we only required 500 specialized engineers. Okay, so you can see here they required more number of engineers than our. This is due to the greater efficiency what we are following, greater automation, fewer footprint on the site, and fewer visit required because we use zero touch provisioning. Zero touch provisioning means you don't require to send an engineer to the site even to power on the switch of your eNodeB or gNodeB. It will be power on from the NOC. Okay, we can fire the command from the NOC and the site can power on. Or if you want to give the restart to of the site, it can be done from the NOC, from the centralized data center, or remotely. All right, the shorter visit, lower specialized per engineer, and everything. If you totally if you consider, we only required we are 20 times greater efficient than the traditional operator in the cost. So this is the overall in the installation, and in the integration, we are very much cost effective, and we have already proved that with the Rakuten Mobile compared to the typical operator. Let's get understand the installation and what key point you need to consider in this installation. We will discuss these reference images based on our based on our architecture, which we have deployed or which we need to deploy for the O-RAN. Okay, for any customer. So first of all, there should be a site. So that the site you are going to install with the antennas and other modules. It could be radio modules as well, and you are going to route the cables through a certain area which is already defined in the towers. Okay, there will be always a location to install the antenna that you need to follow, and also you need to follow that orientation of the antennas. It should not be deviate even 10 degree from the original plan. If the plan is to deploy antenna maybe on 0 degree, let's say 90 degree, and let's say 200 degree. So the orientation of final plan should not be or final installation should not be differ by even 10 degree. So you have to be more efficient here while installing your antenna. Okay, the next part is so let's talk about before installing the antenna. You need to always take care the environmental issues, and you always need to keep in mind that there could be a rain, and you have to protect your equipments from the rain. So always do a weatherproofing or waterproofing wherever is required. Okay, wherever is a connector. So there is a certain weatherproofing that you need to follow. Otherwise, if there is no weatherproofing, there could be maybe water ingress, and that could cause in losses. So you may face a higher recoveries if you have not follow the steps during the installation. So proper weatherproofing, proper labeling of antenna. That labeling is very much important. These labels are very much important, and these labels are defined by so this is not the standard. Operators follow their own labeling models, that how they are going to decide, because they might use multiple carrier in without will decide the procedure or labeling plan, that how you're going to plan the how you're going to label your cables which you're going to connect with the antennas and RUs, right? So why this is important? Because antennas always have multiple ports. Okay, because nowadays we are having tri-band, even pentaband or dual band antennas. It's not a single band antenna where you can you require to integrate only three or sorry, not three or 2 or 4 cables. It depends on MIMO scheme. If it is MIMO 4x4, then you have to integrate. We have to connect 4 cables, and if it is 2x2, then 2 cables. So nowadays it's not only single band antenna. We are using in most of the configurations, and it based on the customer availability for which you're working. If the customer is having 2 carriers, then you have to purchase dual band antenna. If the customer is having 3 bands, 3 carriers, then you have to purchase tri-band antennas. Tri-band antennas where you will have 3 bands in same antennas. So you no need to install multiple antennas for multiple frequencies. There will be one antenna in one sector for for all the frequency, all 3 frequencies. So obviously you have to mark the labeling with the cables, so that there should not be any swap in the jumper cables. if there is swap, swap can contribute the losses in the coverage, because also in ambiguity with the sector. So maybe in the direction of sector alpha or beta, you might get a different sector. So that ambiguity will be there if you have not planned, you have not followed the labeling, and this is applicable if antenna is passive. Okay, remember, if antenna is passive, then this is important. If antenna is active and the radio or ORU is integrated with the antenna, then this is not required, because you don't require jumper cable in that scenario. Okay, so I'm just explaining the possibility that you might have with your operator. If it is integrated, then you don't require this. But if it is separate ORU, then jumper cable is required. Maybe it could be a small jumper cable, 2 meter or 1 meter or 3 meter, but you have to follow this labeling procedure to ensure that there should not be any swap in the jumper cable. Okay, always remember, and always follow this procedure. So this is one part which you are focusing for site installation. The other thing is city POPs installation. The city POPs is another term, you can call it as edge data center or forest data center. So this is the edge data center, city POPs. So there will be a location, maybe a building or any shelter where you are going to install the rack, and inside the rack you are going to install the servers, your DU servers. Okay. All right. So there are certain different approach you need to consider while installing the city POPs, because it should be air cooled, because all the servers which is having high capacity that required air cooling, and certain position of airflow of those servers you need to follow, and also the number of rack, that how many rack you are going to install in that shelter is defined by the requirement of number of servers. Okay, so how many rack you will install in this city POPs is decided by the servers which is required for the DU. So you have to dimension first the number of servers, and then what is the offered power from one rack. Okay, and then you are going to calculate your total number of rack that you can install in the city POPs or in edge data center. So the two part we explained here. Let's understand the other architecture part, how you're going to deploy for the ORAN. Okay, let's get a little bit more on the data center design and installation. So there could be multiple data center, as we were discussing from the previous slides, that it could be a city POPs, it could be a district POPs, it could be RDC or CDC. So like city POP or district POPs, you can install the VDUs, and VDUs will connect with your site where you are going to host also the RU along with the antenna through the front haul interface. Okay, and for ORAN, Open RAN, we are using this front haul interface bit with 7.2x split option. Okay, so this is this split is from ORAN Alliance, and this is what it differentiate us from the other traditional vendors. 7.2x split give you the freedom to choose any third-party RU from ORAN ecosystem. ORAN ecosystem means whoever is following ORAN specification, any vendor you can select for your RU deployment. All right, so you can correlate if you are already working for traditional vendors, that for them, there is no change if you're working for a vendor A. Okay, so the same vendor is going to install the RU and the BBU, or in the 5G they call it as DU. So from same vendor it should be DU and the RU, but for us it could be different because we are open. We are open here and here. Okay, so this is what little bit extra information or in terms of value addition I wanted to give you for during this during explaining this architecture. The next part is like RDC. So you can install your VCUs in the RDC, or you can install VCUs in DistriPops as well. Okay, that you all need to plan. CDC, you can install core or other IMS equipments. So let's consider, because this is very much important for the ORAN and the vRAN, because single ORAN cannot be fulfill all the things which we were discussing since the beginning. Virtualization is very much important, and virtualization you can get from the split architecture. And for a split architecture, you have to introduce the data centers. All right. So let's understand if let's say if you are installing one data center, you can call it as Forage, CityPops, DistriPops, Forage data center, Edge data center, remote data center, or centralized data center. So as I told you, there should be a server, the size of server, the dimensioning of server, the type of server, it's wheel-based or fixed, and that you are going to install inside the cabin. That is how it's original picture on the Rakuten. So that is how it look like. It's servers, and there will be a certain procedure you need to follow for cable routing. Okay, it should not be haze with the cables. So there will be a certain procedure you need to follow for the cable routing. There will be a tray for the cable routing as well, and there will be power modules. So these are the power modules of each rack, and these power modules could be 12 kilowatt or 10 kilowatt. It's depend on the type of servers. Now, based on this kilowatt, 12 and 10, or any other values, you are going to calculate that how many servers you can host inside one rack. Okay, so these are the racks: rack 1, rack 2, rack 3, rack 4, rack 5. So you calculate. Okay. Also, you have to consider the cable length and cable routing. The number of servers I already mentioned. The servers fan flow, it's a front or back, and also one server max power on a certain load. So we usually consider that this server will give you this much of power on 70% load, 50% load, or 100% load. Okay, so customer maybe ask you to calculate or dimension the server based on the 70% load. So accordingly, you have to calculate your number of or quantity of servers. So this is the example of CDC. That is how our CDC. This is our again original picture from Rakuten. So this is how the fiber cable routing and the server installation is done in the Rakuten, and this is the data center, Edge data center. So now you got to know that how CDC deployed, how regional data center deployed, and how Edge data center deployed. Okay. The next thing, let's consider the other part of installation. So this is a full type of installation. Okay, in a dense urban clutter. So this is a one kind of clutter, maybe it could be dense clutter. You are using pole site, and this antenna is integrated with the radios, and this is the mechanical tilt which you have to keep according to the original plan. Okay, and the another installed radio is from millimeter wave. Okay, this is on the 5G. This must be N257 to 57 band radio, which is integrated with the GPS. So this radio is having a 3-component antenna plus RU plus DU. So this small antenna with the small device with antenna, radio, and DU, and also for synchronization, because in O-RAN synchronization is must. we need to synchronize our L1, layer 1, as well as network parameters. So we install NTP server for network parameter syncing, but for L1 parameter day-to-day syncing or synchronization, we need to take input of PTP and syncing. So that PTP syncing we need to generate through the Grandmaster, and that we are using Grandmaster as GPS. Okay, so you are installing this, and this is a sub-6 frequency RU. So this must be N78 or N77 band, which you have installed here. So again, this is 5G but different band, and maybe the connector to or clamps can be different with different radio bands or different antennas. So you can see this have different clamp, and this have different clamp, and these clamps are also active. So I mean, this also have a RAT modules. You can see that RAT is connected. RAT cable is connected with this module. Okay. Again, this is so this is a multi-site, multi-frequency deployment. This site is with LTE integrated with the RS and antenna, and on top of that, we have deployed the 5G sites. So that is how you can also plan for your nominal. Maybe one site could be could work for both your 4G and 5G. Okay, or might be you have to mainly for the higher frequency in the 5G. You need to choose certain poles or certain walls in the street or market for the standalone deployment of 5G radios. Okay. All right. So these are the rectifiers and battery, power box on the site. So this is the complete site of O-RAN. Okay, this is what you require. And if you are working for the traditional, you can compare it on traditional, how many things are required, and what is the what amount of equipment you have to keep on site. Right here, just a small place in small pillar, you have the rectifiers, you have the batteries. It's a lithium-ion batteries, very small, and antennas and 5G antenna with the integrated DU. Right. All right. Let's go to the next slide and see our complete 4G installation. So obviously, you understand the sectorization. Usually in the planning, we consider 3-site deployment. So it could be site sector A, sector B. Okay. So let's see this picture. Here you don't require any jumper cable. Okay. This RU is integrated with antenna. Okay. So there is a 4-port, 2-port below, and 2-port on upper side of antenna. So usually, basically, we are using 4x4 antenna for this band in the 4G, and there is no jumper cable. So whatever jumper cable loss is, that usually 4 to 5 dB, we have reduced here, okay, in our deployment. So obviously there will be more coverage from one side, and that leads to less number of sites deployed in that area compared to the traditional, okay, because there will be a more losses due to their jumper cable and all. And in sub deployment they are using jumper cable from all from antenna to base of the site location, so there will be more jumper loss, and due to that they need to install more number of sites. But if you're following this approach, you might require less number of sites. And if you remember, I told you about that how less resources you required on site for site visit or site RF drive test or integration or commissioning purposes. So this is one of the use cases you can see here. You can see here our site visit is not done through the engineer. It is done through the drones. So our drones did the site visit for their maintenance and their inspection. So you can consider how many how cost effective it is. Otherwise you need to send one engineer for one site. So you can consider if you have 40,000 sites in your country, then there could be a number of engineers and technicians who climb the tower with safety gears. So that always increase the cost. Okay, and for us it's a drone who is doing our that stuff. All right. Okay, this is the deployment in the societies. Okay, so this is the outdoor small cell. You can see this is a normal. This is not deployed by install purposely for telecom grid deployment. This is a normal multi uses poles. This might be deployed by government bodies or municipality corporations. So you can use the same pole and deploy your site. This is what we required to install outdoor small cell. Very minimal footprint on the side, and the rest everything will be on the centralized. Okay, so this is another example. This we are using 5G millimeter wave outdoor. Okay, so you can see here this is millimeter wave, and the other power required for this, the small one, and this could be another millimeter wave outdoor sites. Okay, so very small footprint, and you can solve a purpose. You can fill the coverage gap. So this is how installation is done in the ORAN, and this is actually a deployment, not the hypothetical one, and that we have deployed already in our deployment. Let's say if you are planning for indoor society or indoor office or indoor building. So this is from Rakuten, which we have a LT plus Wi-Fi small cell product. Okay, and the key part is this is is a 2x2, and it have these are the some of specifications which is mentioned, and the important point is PoE, power over Ethernet plus controller. So this device is having DU functionality as well as RU functionality and the antenna. It's a small device equipped with DU, RU, and antenna, and it's power over Ethernet. So you don't need to connect a power cable with this device. One device can can use as because that cable is PoE, so that can be used for data transfer as well as power. Okay, and you can plan any indoor site locations. You can consider anyone. It can be a mall, it can be a indoor stadium or indoor office or any residential places, if efficiently with ORAN, and you can deploy it very efficiently without any hassle. Okay, now let's come to the cost-effective and simple installation with the concrete pole. So this is the concrete pole which we generally use for our deployment, because this is cost effective. It's 40% cost effective than other mediums that you can use for a site deployment. If you want more height, then you can use one extension and connect your microsites. All right, it's easy on the deployment. For the deployment, ease of access. Okay, and for security purposes, you can install other things on not nearby the ground, or maybe on some height. Okay, and it has very lower footprint, so nothing is there. You can see only this thing on the side and this thing on the side, and this antenna. Okay, nothing else. This must be a power battery, rectifier, and power. So please keep in mind this site is also having the power. If you want to run on with only AC power, then please remove this thing. If you have ample or sufficient battery or battery medium power or electricity, and you don't want to give the power backup, then you don't require this. Only this much footprint you require in the site. Only antenna is visible. Here are some indoor radios, and this is how it installed. You have to keep in mind always the while installing the site, the mechanical tools, and always other things like as told you, orientation and all. So this is some of example how you can install the things in indoor. The another part is very much important, which is for headnet kind of environment. So let's say if there is one building and you want to cover this building, okay, so you can go with the headnet kind of deployment for densification of indoor. So in the floor you can plan your sites like this, multiple sites in indoor, and also for cover up you can have a macro site. Okay, and that indoor site will be integrated or connected with the microsite for resource pooling and all. So one site outside approaching towards the building for coverage and capacity, and also you can have indoor deployment with some small cells. Okay, so this is fast deployment and it's cost effective. Okay. Okay, one more thing. If you remember, I explained this part, symbol part, because I told you that our main motto is software centric and automated, or automation, full automation. So we have our platform, which is part of SimWorld, where you can automate your entire network lifecycle, and you can manage from one application. Okay, it starts from plan, build. So whether it's a logistic or any warehousing part, that you can do with the same tool. Okay, it's secure. You can monitor it from here, and you can also, if you want to optimize or fine tune, you can do it from here. So same tool and multiple things. that enhance your automation and reduce the chance of error or any mismanagement. Okay, if you remember, I told you about this installation drone inspection. Only 30 minutes is required to inspect one site from the drone. Okay, and it's very much cost effective. You can obviously think about it, how much it can give in terms of cost efficiency. Okay, last slide. This is just on holistic view. Once you install the site, candidate has been finalized. So our ACE data center deployment can be completed within a minute because of the tools which we are using for the different stages. So if you remember, I told you that the same tool you can use to submit your survey. You can use to scan for the delivery confirmation, shipping purposes, construction purposes, and also you can check and scan with the same tool whether that same tool is installed on that site or not. Okay, during the auto commissioning, the same process or the other part of that tool you can use for this equipment verification, and also this doing the commissioning and auto commissioning and provisioning. All right, so obviously that all gives you the faster cloud deployment and site deployment and data center deployment, and this is what we done with the ORAN compared to the Terrace. So this is all about for me, guys, for today's session. Thank you very much for listening me, and hope it will add some knowledge in your with your existing knowledge which you have already with the candidate selection, planning and designing of site, and also how to install the site for the ORAN. So I hope it will benefit you in somewhere. Thanks for your attendance. I appreciate. Over to you, Richard.
Thank you, Abhishek. Yeah, so there's a lot of information and yeah, insightful data that you have given again. Let's move on to our question and answers. I think that there's a lot of questions in the chat, in the Q&A box. Let's start with Carlos Saul Perez. He mentioned what is the ORAN typical configuration deployed in Japan. So greenfield, 4G, 5G, and what are the frequencies or rural or city, like that?
So basically, in Japan, we started from the greenfield. We started in 2018, and now obviously one site is installed, and if you require to fill the coverage gap, you have to consider brownfield perspective as well. But yes, we started with the greenfield. We deployed our network on the 4G as well as as well as on 5G. So 5G we covered. We deployed on sub-6 gigahertz frequency and millimeter wave. So the picture which I show you in the installation slide was the actual pictures.
Mm-hmm. Okay, thank you, Abhishek. Follow-up question from Carlo on slide 11. From ORAN Rakuten, what is the maximum distance between the ORU and the ODU? Is only one fiber for EC3, and can you use router to extend the EC3 distance?
Yeah, so To answer your first part, there is 3 questions. What is the maximum distance between ORU and ODU? So Carlo, that all depend on the latency requirement. So if you have attended my previous session, the latency on the front haul we required for LT it's a 160 microsecond, and for 5G it should be 160 microsecond as well. And that latency you can get from typical dark fiber kind of setup, transport media. Okay, so if you are using the dark fiber, the usually the distance calculation is based on certain configuration, but in on high level I can tell you the distance could be 10 to 40 kilometers, or not 40, it could be 10 to 20 kilometers.
Okay.
And
okay, please go ahead, Abhishek. Sorry.
Okay, and the next question was okay.
The question was, can you use a router to extend the EC3 distance?
Yeah. So Carlos, actually using router will give you the losses, and if there is losses, then latency will increase, and that limit your distance from ORU to DU. So there is a drawback if you use the routers. So the router we generally use for aggregating the CPRIs, and if it is required, then we also use router for timing PTP and syncing for Grandmaster. Okay, in LLS C3 configuration. Okay, so apart from that, aggregating the front haul and the timing, we don't use this for increasing distance.
Okay. Let's continue on the question and answer, Abhishek. From Carlos Saul Perez, can you share the data sheet for an ORU from Rakuten's AAU active antenna unit, and what is the maximum MIMO supported?
Yeah, so we are supporting 128T, 128R, as well as 6040, 64R for an 257 millimeter wave.
Okay.
And 32T32R for sub-6 gigahertz frequencies.
Okay. Another question from Benjamin Labadan. In submitting the documentations to the customer, the telco operators concerned, and government regulatory bodies, will the designer submit 3 sets of documents, like the nominal plan, semi-final plan, and finalized plan? Maybe it's that's it, no? Because it's very long. But his question is that if there are 3 plans, the nominal, the semi-final, and the final, how many documents they need to submit? Is it 3 or only the final plan?
With whom? Government bodies, he mean? To whom he want to submit? To
the government regulatory bodies, telco operators concerned. But typically, if the radio design is complete, you will submit it to the, like, for example, installation team, right? And integration team.
Yeah,
there's no
for government regulatory bodies, always you need to submit the final plan.
Yeah. Okay. So the final plan. From August Kimson, hi Sir Dubey, for the implementation part, what is the testing procedure for you to know you have maximized the efficiency of the network?
Oh, testing. I will not go into more in the technical details, but what I have shown you You hear that we are getting 20 time efficiency in the installation because of those automation effort which we have implemented here with our installation and deployment. And throughout it start from site survey to site deployment, and also the number of the specialized engineer required in ORAN in our deployment is very less due to the drone inspection and all. So that give us more efficiency compared to the other vendors.